A couple of words about square roots. Okay, the square root of a product of two numbers is the square root of the first plus the square root, or times the square root of the second. However, the square root of the sum of two numbers is not equal to the sum of the square roots, unless one of the numbers happens to be 0. Okay, so I can prove this. If you multiply the square root of AB times the square root of AB, you get A times B, because the square root of a quantity is the number you multiply by itself to get that quantity. By the definition of a square root, this has to be true. Well, if I multiply square root of A times the square root of B by the square root of A times the square root of B, I get what? Well, I get the square root of A times the square root of A times the square root of B times the square root of B. And why is that? Well, I've got 4 numbers to multiply. I can change the order of multiplication. Multiplication is commutative and associative, and there's a little longer proof. This isn't a rigorous proof, but we know that when you have 4 numbers, it doesn't matter in which order they're multiplied. Well, here are 4 numbers. We can multiply them in any order. I choose to multiply them in this order. But of course, A times A is just A, and B times B is just B. So, again, if I square this, I end up with A times B, just as if I had squared this. So that the square root of a product has to always equal the product of the square roots. However, A plus B is not, square root of A plus B is not equal to the square root of A plus the square root of B. Okay, if I square the square root of A plus B, I get A plus B, because that's what square root means. If I multiply the square root of something by the square root of the same thing, I get that thing. If I multiply the square root of A plus the square root of B by the square root of A plus the square root of B, you might think that I would get A plus B, but I don't, because of the distributive law. This equals the square root of A times the square root of A plus the square root of B plus the square root of B multiplied by the square root of A plus the square root of B. And that equals what? The square root of A times the square root of A plus the square root of A times the square root of B plus the square root of B times the square root of A plus the square root of B plus the square root of B times the square root of B. Then, of course, then, the square root of A times the square root of A is A. The square root of B times the square root of B is B. But I've got these 2 terms here. And unless either A or B is 0, neither of these 2 terms is 0. They're both positive, and in fact, they're both equal. I'll do a couple of steps here. I'll reverse the order of the multiplication between the square root of B and square root of A to get this. And we see that I get A plus 2 times the square root of A, B, plus B, where I've combined the square root of A times the square root of B into the square root of AB, because we've seen here that I can do that. So, this is true, this is not true, this is not equal, and I'll put a little qualifier here, not equal to A plus B unless A equals 0 or B equals 0. Related to this, I had to debate for a minute whether I had room to do this, and I wanted to do it here. I think I do, because it's so closely related. The square of A plus B is not the square of A plus the square of B. A plus B squared is A times A plus B times A plus B, which is A times A, which is A squared, plus AB, plus B times A, plus B squared, which is A squared, plus 2AB, plus B squared. Now this looks very much like what we did here, except I don't have square roots in front of things. Okay. Looks like what happened when I squared this. I just used the distributive law. And this is not equal to A squared plus B squared unless A equals 0 or B equals 0. Because of course, if A is 0, then both AB and BA are 0, so the 2AB goes away. If B is equal to 0, same thing happens. 2AB is going to be 0. You're going to just be left in either case with A squared plus B squared. But unless that's the case, 2AB can't be 0. 2AB can only be 0 if either A or B is 0. So there we have a set of kind of related ideas that are the source of a lot of avoidable errors and misconceptions when we try to do pre-calculus, or pretty much anything, or even to do just algebra. Okay, so be sure that we understand these things and understand it in terms of numerical examples. I'll probably go ahead in another video and do numerical examples of each of these.